Welcome back. Today we're going to be taking a look at inheritance and how we can use it to do some pretty cool stuff using Java. Let's go ahead and take a look. So inheritance is the main topic we're working with, and it's not that somebody rich died and is giving me loads of money. No, that's just the thing that you might happen in a novel sometimes, especially something set in maybe the 1800s. But yeah, not anymore. Inheritance in computer science is a hierarchical system that's going to show the relationship between one object over here and another object over here, so we can show the idea of saving both time and code when we write the actual stuff to work with them. Now, it only works in Java with objects only, so primitives don't count, so don't worry about them at all. It does share code and functionality across multiple types with a capital T, so I can share functionality and logic across multiple things. So this really does a lot of good stuff for us when we're doing big scale projects or doing some small scale things where we want to show relationships really well. It also really makes it easier to make object-oriented programming easier to work with real-world concepts because I can define a type over here and then work with it over here, here, and here for subtypes of that, and I can really save some idea and logic work on that so I can make it so it's easier to do some cool things. So that's the real reason for that. There's a whole bunch of vocabulary that goes along with inheritance in computer science, specifically in Java, and so we can see right here we have a parent class, a child class, and subclass are three things you'll see just as generic concepts will work specifically. The super parens and super dot are Java-specific keywords we'll be working with and talk about here. Overloading and overriding deal with how we work with methods in Java and computer science. At override is an annotation for Java overriding a method for inheritance. Final is a keyword. We'll see some specific things like some things can't be inherited because they are final. Protected is a specific keyword for inheritance-based visibility. We have the is-a and has-a relationships we'll see. The instance of keyword is a really cool one for Java. We'll see that in my intermediate or advanced video. Abstract also is a special keyword we can use when we're working with Java. And extends is the keyword we do for actual inheritance itself. Implements deals with interface and how we can have special method-based polymorphism as well. And then this keyword is talking about the current object as well. So those are the just quick vocab words we'll be talking about, and we'll see as we go through this lecture and others on this topic. One of the biggest benefits we have with inheritance is it allows for a subclass access to all the public data and the methods in the parent class. So everything the parent class knows, the subclass has access to as well, and it's really amazing. It saves us lots of energy and code. We don't have to do extra work for that. You can also customize existing methods in the subclass by overriding the parent class method. That's where that at override annotation comes into play. And so you can say, oh, I'm going to do the same method name, the same signature on this, but I'm going to do a special version just for me because I've got that subclass logic. I want to make sure I make it special just for this whole subclass instead of the generic class over here. You can also overload methods, again, so you can have multiple methods with different signatures, and you can do some cool stuff with that. But the idea of this is you can really have customized information for your different types you're working with. It really makes things really cool. Now, batteries aren't included when we're doing this. Now, inheritance doesn't provide access to any private data or the constructor. So private data that exists inside the parent class does not get shared down to the subclasses. So this is a reason 8,000,003 for appropriate getters and setters. So if you do need to access and or modify that information, you want to make a getter and or setter in the parent class for that so you can access the information in the subclasses. And that's one of the reasons we practice writing those at the very beginning, so we always have access to that data. As we do more complex and more involved things, sometimes we only want getters for things, but we don't want to have a setter for that, and that's okay too. But we'll talk about that and see how we can work with that as we go through the project and work with these on here. Now, because constructors aren't inherited, we use the super parens call instead. The constructor must have super parens as the first line of the subclass's constructor. Now, I always require for all subclass constructors, even if it is just a single empty parens on there. Java doesn't require that on there, but the parameters depend on the parent class of that, not the child class. So if your child class has 2 parameters, but the parent class only has 1, you can only call super with 1 parameter, obviously. So make sure you send the information up there. That's how you initialize all the parent class information that you can then access back down in your subclass information. And it's really good. I always require as the first line on there, even if it's just an empty parens on there. Java doesn't require an empty parens to be called explicitly because it'll call that implicitly. But I like doing explicit calls because it makes sure I know I've covered my bases and do that for it. The parent class, again, we only have access to public methods only. It can often be in a different package, especially if we're dealing with somebody else's code because, oh, I'm inheriting from JFrame or JPanel. That's in the Java x.swing library. I don't write that. So I have to make sure I go and inherit from that. So parent class, you have to make sure you have that in the correct package. So you can have an inheritance across package lines, which is really pretty cool. The parent class defines the structure for all of our subclasses. So here's the idea we're working with, and subclasses then fit within that basic parameter structure. Now, one of the things that's a bit different from the biology perspective is parent classes have 0 idea/clue or even access to subclasses. Parents generally have some idea that they have children. But in the Java land or in computer science land, there is no relationship between the parent class and the subclass. The subclass does know about the parent class, but the parent class has no idea whatsoever, nope, not at all, about any subclasses that they may or may not have. The object is the root class of everything in Java. So what everything we've been working with in all of our stuff in Java have all been objects, capital O. And so all classes will either inherit from object either implicitly, just the class, its public class, whatever name. That means there's an implicit extends object. You can explicitly extend object, don't do it. Or you can indirectly inherit because you have inherit from this, which in this and this. And so everything is an object. So every class we've created and or used in Java has been an implicit inheritance from object. Even our runner classes, when we just start up our code, those inherit from object as well. Now, objects can explicitly inherit from the object class by writing extends object as part of the class header. We don't do that because that's a total waste of time, and we don't need to explicitly say that because that's part of the actual Java language. So I don't recommend doing that at all. String, scanner, ArrayList, JFrame, JPanel, and all of our Pokemon subclasses inherit indirectly because we have there's the public class string. It doesn't have to say extends object. We've been using strings all year long, but they all have the fact that they are objects as well. So we can have that indirect inheritance because of that. The methods that object provides, hashcode, equals, and toString, are the most useful ones. There's a couple others in there, but we don't really use them that much in our class. But you can take a look and have that. And the fact that we have a dot equals method we can compare objects is really quite often helpful. And then we're doing it with advanced data structures. That hashcode method is really pretty cool too. And we've been using toString and overriding toString because we don't like the garbage it gives us by default all the time. Now, we talked a little bit about this earlier. Superparens is how we access the constructor of our parent class. Now, again, parameters are going to be defined the parent class's constructor, but we can't see the constructor at all. So instead, we use superparens to reference that parent class constructor, and we send the appropriate parameters to that. You can only go one level up, though, however. You can't go up to your grandparent's constructor. No, you can only go up one level. So superparens has a one level up that we can go on that. So you can't change the super.super like we saw with that. It does need to be that first line of the subclass constructor. Now, like I said, I expect superparens as the automatic class first line constructor on there, even if you only have an empty parameter on there, because I want you to be in the practice of correctly using superparens always as that first line of your subclass constructor. Java may not compare or may not care about it, but I do, and so that's why we always do that. Super dot is a little bit different. Super dot is how I access a parent either data member or method. In my case, it's always going to be data. It's always going to be methods on that because data member is always private. But that's how you access any public method, and that's why the data is in tiny little things because we don't want to do that at all. And it performs that runtime information of the current object, not that of the parent. So if I call super dot whatever, but I have private information or information my subclass level that defines my subclass information, even though I'm running the parent class's method, the information or the data that's attached will be that of the subclass's type because it runs based on the runtime information of the object that calls it. And so it is important to keep track of what type is calling that method because when you're using that, like, oh, I'm calling this other method over here. So if I have methods that are shared across things, making sure I know what's coming back from that is kind of important. There is no restriction where we call super dot in a subclass at all. I can call super dot in a constructor of my subclass in any method, even if it's not the same method signature on that, because I can just reference the information from that and then use it back inside there. I often use that inside the toString to get information, so I can call the parent information and then access the subclass information inside that as well. You can even be called a method that's not part of the parent class, because it's like, oh, I can call that in there and go like in my own subclass method, it's like, oh, here's this special method over here, but I want to call super.parent method to get information from the parent class and use it in this other completely unrelated method because I have access to that information because of super dot, because I can go up a level and grab that information for me. Now, subclass behavior is the next thing we're looking at. So each subclass, again, has access to all the public methods and data defined in the parent class, and behavior, again, like I said earlier, is defined at runtime. So if we declare a variable as a parent class but initialize as a child, it behaves as a child. So animal test equals new kitty means that test is a kitty, but it can be stored inside an animal object. So I can put a list of all animal types and I can put that kitty right in there with no problem. I can do all kitty type methods if I use a casting on it, and it has all public animal methods can perform as well. So it can only do the kitty type methods if we cast it properly. So just that's the only thing you have to keep in mind. Polymorphism is the last thing we're talking about for this introduction to inheritance. So it's a root words for poly in Greek meaning many, and morph also Greek meaning shape, so many shapes that can fit inside it. And this is really how we can use in data structures to make inheritance even cooler. So any angle bracket type that we're working with inside there can hold a parent type inside a subclass. And so in this case, I have an array list of Pokemon. So as you can see right here in the right-hand image, I've got my Amora, my Mimikyu, and my Electrode all going inside my Pokedex because it's a Pokemon type, but I can fit any subtype of Pokemon inside that, and it works amazingly. And so that's just a quick little introduction of how we can work with inheritance. I hope this is helpful. Have a great day. Cheers. We'll see you next time. Bye-bye.